Hello YouTubers. This is the fifth video where we continue to talk about building enterprise level Blazor applications. In the previous video we talked a little bit about initiating and setting up the business logic in a view service, and we touched base a little bit about how view services are basically playing the role of a mapper. The mapper basically allows you to to take an input from the user, detect the input from that user, and then send that feedback right back to the API. This diagram here really illustrates what we're working with. So as you can see here, we already talk about APIs and integration between brokers and APIs. There will be a little bit of more talk around the security and credentials and all that kind of stuff. But also you have here the services, you have the view services, and then once that's done, we will start getting into building the actual UI components that supports a particular Blazor application in a very simple way. I hope you really enjoy that process. So without any further ado, let's just go ahead here and start talking about finalizing the view service, right? We started the view service, but we didn't really finish all the stuff that we wanted to do in the view service. Let me increase the font here for people on their phones just to make sure that things are easy to read. There we go. All right. So this is my test. This is my solution tree. Let me zoom out a little bit. There you go. There you go. All right. All right. So last time we talked about the validation. We talked about the business logic for a particular view service. So we built this student view service. And just like any other service, it has some dependencies. View services mostly are some sort of orchestrators in their own way. So they basically combine two things. They might talk to the datetime broker. They might talk to the user broker. They might talk to user service. They might talk to the actual business logic, just to make sure to combine all of these services together to push through the right information, the right data to the API or the broker neighboring services. But in this particular instance here, because let's just step back here a little bit and let's talk a little bit about some concepts. There is a form of programming called defensive programming, defensive engineering, when you make sure that everything is being validated, your account for every event, and at least you have a catch-all for all the other events that you may or may not really be aware of, right? There's another aspect of this, right? It's very naive, very naive to think that just because you built the service that's a dependency for another service, that you should rely on the validation that the next layer of services is going to be using. Simply because if this guy changes everything, like our architecture or the software that we built, everything there is replaceable, configurable, and modular, meaning that at any point in time, someone could just come in and say, okay, I don't need this service anymore. I'm going to add this service. And maybe this service has completely different set of rules for validation than the existing one that was in place. You should not trust any other services in your system to do the work for you. Every class, every service should either do the work or delegate the work, but not both. So in this particular case here, the view service has its own layer of validation. It wants to say, I want to be the one validating the values that are incoming to me, the ones that I see as required, to make sure that the data that I send downstream are valid data in good shape and good standing. There's also the scenario where people might say, okay, I don't need broker neighboring service. I have discovered that I don't need any of that. I'm just going to talk to the broker directly. Right? In this particular instance, your software should not suffer any additional efforts just to make sure that it maintains, because it's the same contract. Technically, you're mapping into a student view model, and you're sending that downstream for your API to process that. So if you decide to go that route, if that's what you want to do, then you can, like a realistic scenario would be let's say there are no other services that required a broker neighboring service, because that's how it's going to be. Like, you're going to look at these broker neighboring services or foundation services and say, there are other services that may or may not need that information. Maybe it wants to retrieve a student, maybe it wants to update a student record, maybe it wants to do whatever it wants to do, right? So you're allowing multiple view services to access these broker neighboring services or foundation services, to make sure that it does this final validation before it push it through to the API. But if this guy disappeared and this guy was not needed, now you're in this situation where you may just shoot through to the broker, right? Which is not a good idea if your view service is not doing the right validation on it. So let's just go ahead and add some validation in our view service today and also handle some exceptions. All right, so we talked about, when a student view comes in, we basically need to map that into a student, because a lot of the information, like created by, updated by, and created date, update date, all of these are generated internally. There is no need really at this layer for you to validate that data, because you created that data. This particular service is the owner of that. The same thing applies to ID and user ID. Really doesn't matter. So it looks in here that the fields that we really need to care about is basically the gender, which and enum. That we talked about. There's no necessary validation for that. Middle name and last name are optional, right? So these are 3 fields. So the only thing that we really have to validate for is identity number, first name, and birth date. We just want to make sure that that information makes sense, right? Whether it makes sense, you don't want to put business rules in there. You just want to validate structural validation, that it doesn't have null values or empty space or none of that stuff. So let's just go ahead and start writing some tests, for the validation. So let's just go in here and say, because this is a test-driven environment, I'm just going to create a new file in here. And this file is going to be called, so the file name has to match the service like we did before. So it's going to be student view service tests.validations. All right, so these are the validations. And here's some copyrights for the good-hearted engineers. And then public partial class. So that's my partial class right here. And in here, I want to start writing some validation tests. Let's just go ahead and say fact public async task should throw validation exception on add if student identity is invalid and log it async. That's pretty much like we talked before. You have the where, the why, and the what happens, right? So we basically say the action is to throw a validation exception, and this action will happen on add, so that's where things happen, and this is the condition of which this action should be executed when it happens. So when the identity number is invalid, right, and the details of what that means is invalid is what the code is saying, right? What the code is going to be telling. A lot of people go and say, no, let me just go in here and explain what invalid means and say invalid is null or empty. What if it's a white space? You'll see people adding code in here that checks for white space, but they forget to update the documentation. And this is why I always tell people your documentation is important if and only if people don't have access to the source code, or you're generating a Swagger. In general, you don't have source code, right? Or you're generating a Swagger and people want to communicate with your API, or they're pulling in a NuGet library, and they want to call in the method just to know what is happening. Other than that, I don't see a reason for you to actually add any comments in there. Your code should be self-explanatory, right? All right, so let's just go ahead and say we want to create a student first. So here's student view. And this is a random student view. So I generated a random student view. So these are random student view properties. I need a method to generate just a random student view because I'm not doing any mapping in here. So let's go ahead and create a filler. A filler is basically a library that we use out of Dynamics. It's basically a very nice library that fills in the properties of a particular model for you. So like we talked before, if you have a model and you just want to generate random data to run through your test, because the beautiful thing about random data is that it will expose issues in your code that you weren't even aware of, right? Especially if you have very, very particular conditions about, your ID should not be more than X number of digits or characters, or it should start with this particular letter. There are all these different situations and all these different cases where you want to actually generate random data and see how your system behaves against it. There are actually Let's stop here for a second. There are actually two schools of thought as far as I know, when it comes to testing. Some people say never ever use random data when you're testing. Make sure you're very specific about the values that you're creating. So these are unit testing, right? They're testing particular cases, case by case. The question for these folks is, which is what the other school of thought, argues, is that you're supposed to be testing behaviors, not testing particular cases, right? So if you are, for instance, if you're writing a test that says, insert, John into the system, I can so easily go and modify my test to only support, the situation where John is being passed in as a name. But if Ahmed is passed in as a name or Linda is passed in as a name, the system will blow up and not be able to handle it. So how do you work around that, right? I am a very avid, advocate and subscriber to the school of thought that says you're supposed to be testing behaviors, right? Because you're writing code that is supposed to cover as much case scenarios as possible. So you're not supposed to be saying, if your system is adding two numbers, for instance, right? You shouldn't go and say, the expected value is 5 and the input is 2 and 3, right? If you do that, that basically means if there is any condition, let's say a U long or a decimal or whatever the case may be, right? Then you're going to have to come up with these numbers, and I can so easily modify the code. Your test is still going to pass, even though I have a condition in there that literally destroys the entire method or breaks a functionality without your test being aware of it. So always, like, what I advise people to do, because there are all different schools of thought around this, and I'm not saying there's right or wrong. I'm saying what's better, what actually achieves a better goal than one scenario or not. If you want to sit down and write all the possible cases in the universe, by all means, I hope your budget supports that. But if you were to ask me, I'd say definitely go for the scenarios. You have to go for the scenarios for the behaviors rather than a particular functionality. So let's just go back here and talk about the rest of this. So this is a filler. This is a student view. So create student view filler. So that's a filler in here. And then I'm going to go here and say this is my filler. And here is new filler, student view, like this. And then this is the filler setup. And then what does our student view? It has probably a date time. So let's just go here and say on type date time offset. This randomizer doesn't know how to generate. It knows how to generate for all types, but some types are not actually registered, right? So you probably want to provide values for particular types, not particular properties specifically. So I'm just going to go here and say use, and then I don't know, it can be anything. So that time offset UTC now will work. You can generate random dates if you want, but this is our filler. So this is my filler. This is basically just creates a filler with all the configurations and the properties in it that matters to me, because in the future we are going to be building methods that return multiple student views so we can view it and render it in some sort of a grid. This is why I'm separating this method from any other method. I always keep, now pay attention here, I always keep the methods that are not exposed outside of this particular partial class file to the bottom, right? So when you open your code, there's some science and art into how you organize your code so you consume the least possible cognitive resources from the person that's reading your code so they feel like they want to read more. You will notice if you have done software engineering for a long time, 5 years or above, you will notice that some code bases are exhausting just to look at, right? Some code bases, are very joyful. You look at it and you feel like you want to read more and you want to understand more because everywhere you look, there is organization, there is beauty, right? And there is systematic innovation there. You're basically literally like if you look at in here, the order of that declaration in here matches the order of the input parameters, right? Everything here has to matter. The order has to matter. The look and feel of it has to matter. Everything has to look just right. So, all right. So since this filler is just something for the internal use, however, the create random view properties and same student as are not. What is the order now? If you have so starting from the bottom here, right? All of this, get random number and a name and all that kind of stuff, this is things that are only used internally, right? If you go back to your tests in here, you will notice that we don't use any of that stuff. The only methods that we're using, that get random date, create random student properties, and do the mapping and all that kind of stuff. So, okay. So where's get random date in here? Right there. Get random date. Let's make sure that this guy also is on top since we use this guy like this. And then under that, see, now the order of it is based on the chronological order. Like what do we use first? Since I'm adding another method in here, I'm going to go here and say private static. It might be a good idea to actually now use regions and say where is the publicly used versus the non-publicly used. But that's basically the standard that we try to carry forward to build rigid software, industrial rigid software that you can actually rely on and be able to maintain. All right, private static. What was I trying to return? A random student view. So this is student view. Create random student view. So now I get to use this nice nifty filler, create student view filler, and just say create. So create here is basically picking up that filler and creating it. And because it's a one-liner function, I'm keeping it in one line, as you can see. So this is a one-liner. I'm keeping it in one line. Let me zoom in a little bit more just so people can see what I'm doing here. All right, so here we go. Create student view filler. Let's create. It's all good and dandy. Beautiful. Let's go ahead and use that. So back to my validations. I want to create random student view. There you go. And then in that student view, I want to say this is invalid student view. Why is this one invalid? Because I'm going to modify the values of this guy. So it's not random student view anymore. So this is me telling the story of how I came about creating this invalid student view. This is an invalid student view. But what I'm going to do here is that I'm going to pass in a parameter that gives me all the possible bad cases of a string. How do I do that? So this invalid student view dot identity number equals invalid identity number. Where's this invalid identity number coming from? Instead of using a fact here, I'm going to turn this into a theory. I'm going to put some scenarios in here. What are these scenarios? If you have inline data, I can go here and say, well, one scenario is null, the other scenario is an empty string, and the third scenario is a white space, like this. Which means that this guy here now requires a parameter, which is invalid string, invalid identity number, like this. See how I did this? So instead of writing the test 3 times, now I'm just using inline data. Inline data is perfect if you know what data you want to pass in. If you're using calculated data, like you're going to generate some invalid date times, like I'm going to show you on the API side, I probably have already gone through this. Go back to my series on creating OSSS API and look how I did the entire modify pipeline for a particular student. Every single property in that model has to be taken care of, has to be modified based on particular business rules. Alright, so should throw validation exception on add if student identity is invalid and log it async. Great. And these are the cases that I'm taking care of, the inline data theory, all that. So now this guy, this test basically is going to run 3 times. Every time it runs, it picks up one of these values. You see how I'm doing it? So one time it's going to run when the invalid student identity number is null. One time it's going to run when it's an empty string. One time it's going to run when it has an empty space. Empty or white space. All right, so what do we expect when this happens? Obviously, we're not going to be calling the any dependency. And we know that any dependency in the system will not be called. We're going to actually validate specifically, explicitly, that these particular dependencies have not been called. But more importantly, we expect that we have an exception in here, invalid student view exception equal invalid student view exception. And I don't think I defined that, so let's go ahead and define that after. So this is parameter name, name of, right? The name of will basically define the property. And like I said, don't rely on an instance, rely on the actual class property, because an instance could have dynamic data in it. There's no guarantee. So this is parameter name and this is parameter value. And I can go here and say invalid. Actually, let's get it from the student itself. So it's invalid student view identity number. So that's basically me saying this is an invalid identity number and this is how I'm going to create this particular instance. So let's just go ahead and create an invalid student view exception. So in the models area in here, where's my models? Right here. I have students and I have student views. Right? I'm going to create a new folder under this one and I'm going to call it exceptions. I've seen some people put all the exceptions in one folder across the solution. All the exceptions in one folder. That's not modularity, right? It's not modularity because you are already planning to do a heavy, hard coupling between multiple services that throw different kinds of exceptions for different business cases into one place. This is the worst thing you could possibly do to your software. It makes your software very hard to maintain, and if you decide to break each and every service in your system into its own little microservice or Azure function, whatever, if you want to be completely serverless and you want to break each and every one of these methods, because that's pretty much what an Azure function would look like. If you go into my student service in here, in a serverless architecture, this entire piece of code with the exceptions and validations behind it, that's basically what I expect an Azure function to look like size-wise and code-wise. Right? Some people like to push that to the extreme and they build an entire monolithic application inside of the Azure function, and they think that's the right thing to do. I don't think so. I highly disagree with that. So all right, so in the exceptions, let's just go ahead and put a class in here. So we need a couple of exceptions. Okay, we actually need 3 of them, or 4 rather, right? Let's just put all of them in here. So invalid student view exception. There you go. And this invalid student view exception will inherit from exception. And I can go here and say, all right, so I need 2 things. I need parameter name string parameter value. So I have these 2 things, and that's my base class. So let's just go here and say base. And my message here would be, check this out, invalid student view. Let's do it this way because it's a model. Student view error occurred. And then let's put in the information. So parameter name. Here's some string interpolation, parameter name, and then take a comma and say parameter value, parameter value, like this. Then we can take these squiggly brackets in here and just. So here is my exception, and this exception will need to be put inside of another exception, the category exception and the specific case exception. Remember how we talked before about every service has 3 categories of exception: validation or service or dependency. And under validation, there is dependency validation. It's just a branch out of that. This makes it easier to make a fast decision down the stream, or sorry, upstream, when something else is consuming your service. You want to make sure that the service that's consuming your existing service under development doesn't have to actually look at every possible exception that it throws, but rather categorize it under higher level exceptions. And the reason for that is you saw that in the controllers, like in API controllers, if everything that's validation based needs to be just a bad request, then I could just do that. But it's so beneficial for both the engineers and the users to know about the particular cases when needed. Remember how when we went back and said in the HTTP response exception, an API could return a boatload of errors, a lot of errors, right? But there's always a case where we want like a catch-all. So this is the catch-all for the API, and this is the catch-all for the internal service. You have to account for that. Okay, there are particular cases that you know of, but you also have to account for the cases that you don't know of. Like I say, software engineering is like playing chess with Uncle Murphy. Everything that could go wrong will go wrong. So account for that, program for that, and be a defensive programming engineer. So okay, so this is the one service. Let's just click this little icon down here, a little broom, and let it clean this part. So this part is good. Let's go back to our test here and see what else we would need to complete our test mission here. So this is invalid student view exception. If I do control period, it will pull in this reference just like everything else. This guy is sad because I didn't make an asynchronous call and I promised it that it's going to be asynchronous. The next thing is the category, right? So in here is the expected exception that I'm actually expecting to throw. So this is expected student view validation exception. So we're throwing a validation exception, and we're saying this is student view validation exception. Notice something very important here. The language here is different. For the internal exceptions, because the context is given, the context is a given. You already know that you are in a student view service. Tell me what else. Tell me something I don't know. So what I don't know here is that there is an issue, invalid student view exception or null student view exception, whatever the case may be. Right? And we're going to talk about the null student view exception in a second. So invalid student view exception. So that's the specific case. But when you go up above, this is what you're going to throw to the outside world to actually handle the exceptions that you expect to throw to the outside world. We start with the place and then the issue. See the difference here? We start with the issue and then the place where it happened. Invalid student view exception. In here, we start with the place where it happened and then the issue. See the difference? It's very, very important to pay attention to these little details, because that's when you go and you look in your App Insights logs, or you're trying to investigate an issue. Just by looking at the exception name, you already know what happened. A lot of engineers have to go through tons of stack traces just to figure out what actually happened, right? That's not how we're doing it in here. So this is student view validation exception. Perfect. I don't have that exception in here. So let's go ahead and create that exception class as well. Let's go here and say, this is student view validation exception. Under exceptions, put a little bit of copyrights. Make it a second habit for you to, put your copyrights, your conditions, how you want your software to be used and all that. Here you go. And this is CTOR. And then in here, basically, I'm going to go and say exception, inner exception. So this guy takes an exception as an input parameter. But in addition to that exception, we're basically going to go here and say base student view validation error occurred contact support. That's you reaching out. Or basically, if you decide to propagate that all the way to the UI, which we will, that's basically the message that we're going to throw out. And what else in here? We want to basically pass in the inner exception. For the most part with these validation exceptions, let's see what I did in here. For the most part with the validation exceptions, I let the user, I try to say try again because it's on the user side. The user needs to fix this. Contact support, it's on our side. So anything 500, anything that's service-based, anything that you know it's your fault, it's something in your processing, you have to handle it yourself. All right. Student view validation error occurred. Try again, right? So I have this in here, so let's just go back here and actually complete our tests. Our test here should say student view validation exception. This is invalid student view exception, so that's basically me creating the little issue and putting it in a category. And this category, how things are going to be handled. There's nothing else that we need to do here because this is input validation. This is input validation. You're not really going to touch on anything, any property, any service, any calculation unless the input parameter is in good state. So let's just go ahead and say here value task. So we're not really returning any actual parameters. We're actually going to throw an exception. So there is no expectation here of an actual and expected. The expected is exception. So this is a value task of a student view. And this here is add student view task. See, I'm not doing an await in here. I'm just calling the service just to containerize the actual action without the action actually executing, without it running. And then I'm going to go here and say add student view async. And then I'm passing in here invalid student view. So this is me telling the person reading this code, I'm passing an invalid student view. I am specifically up to no good. You know, I am up to no good. I'm making trouble. I'm trying to throw an exception intentionally to validate that my service actually can handle these issues and these cases. Well, if that's the case, then the execution of this is going to happen in the then section where we're actually validating that this actually happened or asserting that this happened. So await assert throws async. What is the exception that I expect to be thrown? This guy here. Student view validation exception. And this guy here will execute to add student view task. So it's like me sandboxing. I'm sandboxing the person who actually developed the throws async is a pretty genius. He's smart. It's basically you're basically putting the method that you're about to execute in a sandbox, and you're saying an exception should happen from here, right? I've seen some test frameworks. I don't know if it's MS Test or something else where they actually go and say in the expected here exception or something like that, and then they describe what's going to happen in the exception. It's one way to do things. There are so many different ways to do things. It's not my favorite way to do this. All right, so this is this guy. What else do we expect to happen? We expect that our logging broker, we expect that we're actually going to log this issue. So broker dot, hold on a second, broker dot log error. And because exceptions that we create in here are not going to be of the same reference as the exceptions that we're going to be throwing from our business logic, we're going to go here and say it is same exception as, and then I'm going to pass in my expected student validation exception in here. I'm going to break in here just to make it look pretty. And it is basically something of the mock framework work. And I don't have that same exception as method. So let's just go ahead and create one. Since this is something that's going to be used publicly, let's make sure it follows the same order. So I created my student view in here. Let's do this. Private static expression. Expression of a func of an exception and a boolean. So that's me basically creating an expression. Expressions are beautiful. They make your code look really simple, and they execute pretty much the same thing. So in here I'm going to say same exception as, and that's an exception, and this is my expected exception. So where is my actual exception, someone might ask? Because this is an expression of a func, then you can actually go here and say actual exception, because it's coming out of, like, what you're returning is a func, an expression of a func. So obviously the func has an input parameter, right? This is what this exception is. You see what I'm saying? So we want this actual exception message to match the expected exception message. And we also want the actual exception inner exception message to match the expected exception inner exception message. I really don't care about anything else because I'm already logging the entire exception putting the entire thing in the logging. This is important because the message that is coming to the engineer, which you have worked so hard on, as you saw, we went in and we said, oh, I want to put an exception. I want to make sure the message is descriptive, and I'm passing in another exception in it. All I care about is the messages, because the messages are going to the engineers or going to the end users. So you want to pay attention to these two particular cases, right? If you can't pay attention to these, and you want to throw in the entire stack, sure, the entire stack will be logged in App Insights, but that's not enough. You want to basically make sure that the message actually is descriptive and it's something that you can validate against. All right, so now in our order here, looks like we're going in the right order from a validation exception. So there's this guy, and then there's, okay, so same exception as, and I expect this guy to be called how many times? Times once. Times once. And this should be a verify, not a setup. Oh, there you go. See what I'm doing? There you go. So these are not on the same level, so we're basically going and saying, okay, this should be called times once and all that kind of stuff. That's great. And let's go ahead and validate the other things. So what are the other things that would chronologically execute in time? Well, you have the user service mock. We want to verify that this service.getCurrent was called times never. We want to also verify that the datetime mock getCurrent datetime was never called. You specifically talk about those, even though you can say verify no other calls, right? But you specifically talk about those because these are the things that would have happened if we didn't run into this validation issue, right? And then the last one is basically student service. We also want to verify that this student service dot add student with any, see, it is any student, doesn't matter, anything was never called. We haven't called this service with any, literally any input parameters. And then at the end, we can go and say verify no other calls. Now, when you verify no other calls, it's going to be the same chronological order. Just to make sure that this is the case, I put in the current logged in user before the date time. Is that really how I'm doing it? Let's see. Yep, I'm calling the currently logged in user and then the date time. Good, Hassan, good job. So let's just do this. So basically in our order, in this particular case, it's the logging broker that was called first. But ideally, see the chronological order of this? Ideally, I would have called the user broker, so verify no other calls on this one. And then I would have called the datetime broker, verify no other calls. And then the last one is the actual implementation user interface. So that's a unit test. Because I'm zoomed in, you can't see it properly, but ideally I am at this level here. You should be able to kind of see the entire test and what it's trying to do just at a glance like this. All right, great. Let's run this guy and let's see if that's true. Have a sip of water here. All right. And this guy failed. Why did this guy fail? This guy is basically saying these are 3 different tests. If I go and open up the Test Explorer in here, if you look at what we have, it will basically say, well, I expected you to throw a... by the way, the Test Explorer will actually show you the input parameters that you passed in. Look, this is your input parameter. So in this particular, see how there's 3 of them because I have this inline data. But for each and every one of them, you could actually see what I passed in. So I'm assuming this one is going to be null. See? Null, empty string, and white space right there. See this? All right. Now, with this being said, it's basically the actual error is that I expected you to throw a student view validation exception, but you didn't throw anything. All right. So let's go fix this, right? First, let's commit this, and let's say this test has failed. See, this is pure coding, meaning that you're a purist. You're basically pushing a commit every time you make a step. And then let's go back to our student service implementation in here. And let's go ahead and create a new file called student view service.validations.cs. So I need the validation.cs. It needs to be partial. There's this guy. And I also need the exceptions.cs, which is the other aspect of the service. See how we are abstracting away each aspect of the service. Like I said, if we are actually object-oriented programming, then we should treat these objects that we created in a 3D instance. And if they are 3D, then they have to make sense. All right, they have to have different aspects that you can look at whenever you want to look at it. So okay, and there's student view service.exceptions. So that's your exceptions. Oh, I forgot the CS. Let's put CS in there. Yes. There's this guy. And now let's also make this one partial because it's a part of the actual class. I love partials. A lot of people will say, okay, I've never used partial. Well, I'm giving you a real good reason to use partials. Real good reason to use partials in here. All right. So what do I want? First of all, I want a private delegate that returns a value task. Can I pull in my references in here? Yeah, this is something I really hate, about, if you create a C# file and you make a little mistake about the extension, it never gives you that nice autocomplete stuff. See, I don't get to have that if the file was created originally with the wrong extension, which is kind of sad. But anyway, here we are, private delegate, and then you're returning a value task of a student view. So there's this guy. And this is a returning student view function. So this delegate here is basically what I expect to be passed into this try catch method, which is again, the noise exceptions, noise suppression pattern that I've introduced to the world about a year ago or so. All right, so okay, private. So this is private, and then this is a value task. Actually, async value task. Excuse me. Student view. Try catch. Returning student view function. We are at 13. Here's a try catch. Perfect. And the exception that we want to handle actually is invalid student view exception. Invalid student view exception. This is invalid student view exception. Here you go. And I'm returning and awaiting the same delegate function, whatever I'm going to be passing in. See what I did there? So there's a try catch. And this is returning student view function. And this is what I'm returning. And in here, I need to create and log, just like I did with the other service, I need to create and log a validation exception. So it's private student view validation exception. Create and log validation exception that takes in an exception as an input parameter, like this. And I could go here and say student view validation exception, new student view validation exception with exception as input parameter. And then in here, I'm going to call the logging broker and log an error with the student view validation exception. And then at the end, I'm going to return, just make sure there's an empty line between all your code and the return, because this is basically your final statement. It's like you're signing. You're saying kind regards, Hassan Habib, or kind regards, Josh McCall, or whatever you're signing with. That's what return basically means. It's art. You're drawing a picture. It has to look great. It has to look really nice. So okay, so here's student view validation exception, like this. And in here, I'm basically going and saying throw, create, and log validation exception with this invalid student exception. Great. So we did the part where an exception is being thrown. We need to hook that up to our business logic. So instead of me going like this, I'm going to fat arrow this one and say try catch async, like this. So I basically wrapped up my entire method into that try catch, and I'm going to take the async here because I'm already calling it. See how your business, you all of a sudden, your business logic is wrapped up in this bubble where if any exception happens coming out of this service, you will immediately take it, handle it, and come back and process it. All right? Well, that's a good deal. It's a good deal. Well, let's move forward. So what am I trying to do here? Next, I need to actually write the validation logic, right? So we said we want to throw an exception if and only if the input parameter of the student is bad, right? So in here, I'm just going to go and say private static validate student view void validate student view, and that's my student view here. Student view, and let's write some rules. So on the student view, I'm going to do a switch case in here. And I'm going to say, if this student view is actually an object when the student view identity number is invalid, I need a method that says it's invalid. So private static boolean is invalid, without actually talking too much about, what does that mean? Because that's basically another layer of details. I want you to pay attention to this piece. Basically, when you're writing code, try to stay at the surface layer, right? I'm gonna jump back to that in a second. But when you're writing code, it's sometimes it's very hard for people to know when to not provide more details and when to provide more details, right? For example, let's stop here and talk about this for a second. If you are building let's say you have these two functions, right? Let's say you have a function here that says add student. And let's say you have another function that says add library card. For the student. It doesn't make sense, and let's say this add student basically underneath it does this. Validate student insert student. And this guy does something very similar here. This is how you stay at the surface layer. So in here, basically, this guy also is calling two methods, validate library card, like this. And in here, it's basically saying insert library card. Right? So you see how these are just functions. And each one of them is calling other function. But then there is this one function in here that says register student. So when you register a student, you want to create a library card for them as soon as you register them. What some people do in their code, they get a little chatty. They get a little chatty in the sense that they go and gather all of this and they put it in here, into this method, into this function. So this function will say validate student, insert student, validate library card, insert library card. It sounds like, if you're familiar with the rule of normalization, when you're just aggregating things based on a common category for them, it sounds like it's much better that you push this underneath and just give it a name as add student. The same thing happens in here. You push this underneath and say add library card, and then aggregate both of these under this guy. See this logic? When you're writing this is separation of concern. This is single responsibility in action. If you go back to our code here, I see some people go and do this, which is really sad. They go here and they say string is null or white space, and they pass in student view dot identity number like this. This is just too much details at this level. Way too much details. What this guy is concerned with is that if something is invalid, throw an exception. What's the validation rules? That's somewhere else. Put that somewhere else. You have to focus on this piece. Don't be chatty. Like a lot of people, they put way too much details and they lose focus so easily into what the method that they're building. This guy just validates. Great. And when a validation error occurs, and the details of these rules have to be abstracted away, right? In that particular sense, isn't it much, much easier to just go and say, and more readable, to go and say string dot is, let's see what happened here. So in here, I'm going to go and say string dot is null or empty or white space, and I'm passing in the text in here. Some people say, why don't you use string like this? Because string like this is a primitive type. It's not actually expected to have any functionality. It's not a class. It's a primitive type. I don't expect it to have functions in it. It doesn't make sense. This looks better, even though Visual Studio disagrees. Visual Studio is wrong in that particular case, at least from my perspective. All right, so in here I'm going to go and say case when this student view is an object. That's what this is. This means it's an object. When is invalid. What's is invalid? Student view dot identity now. See how I'm describing the rule? When this happens, throw new invalid student view exception. This is where you get to the specific particular case of what you're trying to solve for, and say parameter name, name of student view dot identity number, like this, and your parameter value will be student view dot identity number, like this. So if this validation error occurs, throw that particular exception. See how everything is clean and separated in its own place? So it's easy for you to look at and maintain. The last thing I want to do here is to just validate. So validate student view. This is my student view, done and donezo, just like this. Does that make my test pass? I don't know. Let's find out. Let's double click here. Let's click on the red dot here and let's run our test. Let's take another sip of water. Oh, I have a bad thing. Student service, another partial declaration. Ah, this guy needs to be partial because when I built this, I didn't build it as partial. Okay, good. Let's go back here and run this. And now it's green. So that means that I feel safe that the data that's going to go through to this system is going to be validated, structurally validated from the get-go. All right, great. So that's this guy. Let's go build another one. This time we want to validate. This is the one that I was actually supposed to start with. Actually, I'm not even going to declare that method before that one. I'm going to copy this whole method here. I'm going to write another one, except that it's going to be a fact test method, right? And this method is basically going to go and say it should throw validation exception if on add if student view is null, and log it async. Is null meaning that the actual thing that's being passed in doesn't have any data in it, right? Fact. So everything here should stay the same except for one thing. What's the one thing? Everything, well, this is student view. So this is basically null student view. That's null, like this. And the exception that I'm throwing here is actually null student view exception. Don't even worry about the validation because the entire object doesn't exist. And this is going to be null student view exception. I'm going to rename in here, and everything here just should run smoothly. I'm going to pass here null student view exception, and everything here should just be exactly the same. So the only thing that changed here is that the validation rule is that when that student is null, right? So let's just go ahead and create that exception real quick. So you see how these specific cases have their own specific exceptions. I'm going to go here and say null student view exception. I'm going to add in here my rules. So this is exception, CTOR. And in here, I'm basically saying that obviously there's no input parameter in here because there's no student, right? So base null student error occurred. See what I'm saying? And then I can go here and can clean this up. And now I have this null student view exception in place. Let's go back in here into our test and let's validate this. So this is basically saying if this happens, make sure that we call the logging broker and none of our dependencies is actually being called. None of them. So let's just go ahead and run this test and see what happens. Technically, ideally, our hypothesis is that this test should fail. Rightfully so, because we're passing in null input parameters. All right, so this guy is failing. Let's, again, make sure that you're throwing the right exception. So this thing here is saying, I expected you to throw student view validation exception, but I actually got a null reference. Obviously null reference because it didn't validate, so it tried to actually process a null value and it blew up. So it should throw validation exception on add if student view is null and log it async. Let's go ahead in here and just say fail. So this guy is failing. And let's go into our validation. So now all you have to do is just start adding validation methods because you already built the foundation to handle all these exceptions, right? So instead of case object, I'm going to say case null. And when that happens, throw new null student view exception. Make sure you separate the two liners with an empty line. That's all I have to do. This would make the test pass. Let's validate that. Let's go back here and let's go back to our tests. And if I go here and run, watch the fireworks. Good stuff. Great stuff. There you go. And oh, I forgot something. So it still doesn't know what to do with it. So it threw a student validation exception. It expected student view validation exception, but it received a null exception. What's the problem here? The problem is that I forgot to handle it on the exception. See how I handled invalid student view exception? I need one that looks exactly like this. Chronologically, we should validate for null before we validate for identity or anything, otherwise it'll blow up. And then I can put here null student view exception. Null student view exception like this. Here is your student view exception nullability situations. This is null student view exception. And now let's go back to my test here and validate again. Let's see if that works. Here's my test explorer. And here's my test that's running. And it went green. Perfect. So we have a passing test at this point. Here we go. Pass. Great. What else did we say we're going to validate? If I do control MO, it'll just collapse things. The rest of the things that we're trying to validate, one of them is date time, and one of them is the first name. Everything else gets generated, basically, right? Everything else gets generated by the system. So let's validate the student first name with the same exact rules as this one. Let's go here and say, should throw validation exception on add if student name, or rather first name, is invalid and log it async. Like this. All I have to do is just change the identity number to name, first name, and change this to first name, and change this guy to first name. And the rest of the things should stay just about the same. Let's go ahead and run this. This guy should fail. Let's minimize this guy. Here, it failed because there's no student first name validation exception. Let's go ahead in here and log this as fail, like this. And let's go ahead and add that rule into our system. So now I just need to add a bunch of rules because this one is, again, it's going to throw an invalid student view exception. So it's pretty much this exact same rule here that I just copied, Control D. If you do Control D, it'll copy the exact same thing for you. And instead of student number, you want to say student first name. First name, and first name. You can see the AI in your system, it has these three dots. It said rename first name to identity number or the other way around. Sometimes it's not as smart as it thinks it is. So first name, but it's getting there. It's a good foundation. Huge thank you and kudos to the folks working on the Visual Studio IDE to make it more easier and more fun to work with. All right, so I put in this rule in here. That means if I go back here and I run my tests, this guy should pass. Let's see if that's true. It passed, right? So that's great, right? That means that we validated the identity number and the first name. Let's log this as a pass, like this. And now comes in the next validation. The next validation is very straightforward. It'll be exactly the same as this one, except that we can't actually since it's not logic based, we're just gonna go here and say fact, and we're just gonna set the default value for the date time. So birth date default. Someone might say, well, wouldn't you want to add in business logic for when the date doesn't make sense, someone born in the 17th century or whatever? I said, well, that would be the API side. The UI side is supposed to stay really dumb, thin layer that just makes sure that the data looks right before it sends it over to the API. And you have to make sure that you're very clear on this distinguish between what the UI is doing versus what the API is doing. The API is the core backend service that will be plugged into mobile phones, desktop apps, web apps. You don't want to repeat the validation logic across all of these, especially the logical validation. Structural, sure. You want to make sure things are working. At least if you're going to save the information and reuse it in another UI component, you probably want to make sure it structurally looks right. But logically, you don't want to repeat that because that can be huge chunks of data. And some people would say, well, why don't you just create shared modules? I'm like, well, if you're going to create shared modules, then you may as well just put everything in one place and build a huge, ginormous monolithic application, and keep everything in one place. You want to separate the concern even on a service layer, on a business layer, on a system layer, and as you go up above, things should clear out. Like from a 10,000 miles perspective, you will be seeing things that you don't see when you are at a 5,000 miles perspective off the sea level, and then when you come a little bit closer, things start to clear out a little bit, so you want to see the details. Just like how it is in the real world, like in life in general. If you're looking at an organism, if you're looking at, your own hand, right? It's trillions and quintillions of, human cells, right? But that human cell itself, has more details in it, but you don't see it right away. You need a microscope to look closer to see these details. And then there are finer details behind that and finer details behind. Just like the universe, if you're out of space, you see the planet, you see Earth. You don't see all the houses and all the people and what the people are saying and the cars going. You don't see none of that. You just see big blue a planet, and you're looking at it and you see just the overview, the high level. The closer you get, the more details you get to see and the more details you get to learn more. That's how your software should look like. You're starting with the smallest details, maybe a validation layer, and then there's the business logic layer, and then there's the service layer, and then there is the microservice layer, and then the entire architecture layer, and then the entire application. This is how you're supposed to be developing the finer details into every single little component in your system. All right, so keep that in mind. So you can the only way for your software to survive and to become something worth its while is based on how much it mimics nature, because the nature around us, the world around us, is the best software ever. Everything around you is programmed. It has a purpose. It works in a specific way. It has different ways to react to particular scenarios, right? The weather changes, the plants change based on it, the particles in the universe change and react to everything around it. That's programming. Universal programming. Universal architecture. Perfect. Perfect. And the closer your software is to dance with the universe, the pattern of the universe, the more it is likely to succeed. The most popular software that you see today is a software that matched the pattern of a specific human need, like social media, for instance. Social media, for instance, is dancing on the same pattern to fulfill a pattern in nature, which is the need to socialize. Right? The same thing happens with everything else. People who seek information, people who try to build, buildings, and they want to see the overview. The more your software match that pattern in nature, the more it's more likely to succeed. All right, enough with the TED Talk. Let's go back to this piece here. And let's say if student birth date or date of birth is invalid. What does that mean? We're not really passing any parameters anymore. We're just setting the birth date to invalid value. And in here, I'm basically saying, if this fails, make sure that you log in an exception, and that exception is the birth date, just like this. I forgot to do something. This student validation exception needs to take the second parameter as object, because that object can be anything, and that's why I was having an error in here. Because it can be anything. It can be a good, it can be another student, it can be a date time, it can be a Boolean, it can be anything, right? So you want to basically make it an object. So back to my exception here, just for you to clarify, the parameter name will always be a string because it's the name of something, but the parameter value is the object that you're actually putting out there. All right, great. This is all good stuff, stuff that makes me relatively very happy. All right. So we did this. Let's run this application and let's see ourselves failing. You have to fail in order for you to succeed. Only failure will make you appreciate success. All right, so here you go. So this is a failing test, and it's basically saying I expected a student view validation exception, but no exception was thrown. I don't know what happened there. Help me. So let's go to your. Let's first. Did we log this test as failing? Let's log this test first as failing. This fail. And then let's go and make that test pass by simply in my student view here, I'm going to go and say, now this is invalid here, is going to blow up because you're passing in a different type. But I don't want to worry about what the validation is like unless I really need to. So I create just another method in here that have almost the exact same signature. The only difference is that it takes a date time offset date like this, and it goes and say, because it's just structural, so we don't really care. So date equal default. So that's basically us saying if it's the default value, it's not, there's no value in there, blow up. And some people prefer to do some sort of to do nullable dates, and that's fine. So they can check if the date doesn't exist at all, and that's fine. Some people do that. I'm not a big fan of nullable things if they don't have to be nullable. So here's where we stand. All right, does this make my test pass? Let's go back here to my tests, and let's run this guy, and hopefully it'll pass. Here we go, and result is pass. So we basically validated that we're actually check the dates. Wonderful. So this here will be a pass. All right. So that basically wraps up our entire validation session here. We basically created, all the validation layers that we need to do. And these validation properties, we validated the birth date, we validated the first name, we validated the identity number. We made sure that these three parameters, and then we validated this entire object that's coming in should not be, so basically created 9 tests, because there's 3 and 3 and 3, these are 9 tests. There's one for null and one for the date time, and then three for the identity, student identity number, and 3 for the first name, and 1 for the business logic. So these are 9 tests to cover all the scenarios around this part. Just like how we did in the previous service, we need to handle all the exceptions that may come out of this guy. So this guy has its own exceptions. Maybe it called the API blew up, sent back a validation exception, dependency validation exception, and we need to take care of that, right? We need to take care of that. How do we go about doing that stuff? It should be very, very simple. So remember how in our tests in here, we need to create an entire new set of rules. But this will be very straightforward, right? Because you're basically handling dependency exceptions, and you are handling a service exception, and you are handling all the dependency validation exceptions. So there's these four exceptions that may come out of these dependency services that you're calling that you need to take care of in addition to your own. So what does that mean? I'm going to write some set of rules in here. So let's just go here and create a new class, and I'm going to call this class student view service tests dot exceptions dot cs. This is public partial like this. Okay. And in here I want to write few sets of rules. What are the rules that I want to take care of? Let's go ahead and create public static theory data, and these are the student service validation exceptions. What does that mean? All the exceptions that are related to validations that may come out of this particular service, right? So what are these? Well, you can return here and say new theory data, and this theory data will have a generic type of an exception, and it has the following values. I don't even know if we need this guy. I don't think we need. One sec. Do we need this guy? I don't think we need this guy because we're not passing anything in the constructor, right? This is just some old school C#. So what are we returning? The first thing is student validation exception. That's the generic exception that comes from student service. And there's also new student dependency validation exception. And both of these need some inner exception, which is totally fine. We want to go here and say inner exception, right? And we're just going to create an exception in here like this. All right, with that exception, I'm just going to pass in that inner exception here, and I'm going to pass in an inner exception here. So these are basically the set of rules, the things that I'm going to react to the same way. There's another set that I'm going to come to in a second, but let's just write the test first. So that means in here I have a theory, and then I have member data that takes in name of student service validation exceptions like this. Right, here's my service. I'm going to go here and say public async task should throw dependency validation exception on add if student validation error occurred and log it async. Right under the wire here, 118 characters. So what does that mean? Just for people who are not familiar with that, not this guy. If you go into the exceptions, let's say you have like I said before, you have a student view service, and you have student service. One second here. I think I broke it. Let's try another one. All right, let's try this one instead, because I broke the other one. All right, here we go. So let's say you have a student view service, and in here you have a student service. The problem with these two is that if the student service throws two kinds of exceptions, right? Two kinds of exceptions. Actually, it throws more than that, but let's just start with the validation exceptions. This student service already is calling a broker somewhere. And out of this broker, if that broker throws a validation exceptions out of the API, it throws a dependency validation exception like this. See? But it's also doing its own validation, so it's throwing validation exceptions. What we basically do is that we take both of these exceptions, we capture them on the upstream services and turn both of these into one thing, which is a dependency validation exception. You will see by the time we reach to the UI, it's pretty much going to be one exception that you're handling. See how we're aggregating all of these exceptions until we reach a particular point. So all of this is dependency validation exception. Why? Because the dependency of your dependency is a dependency to you. Right? Ipso facto, the dependency of your dependency is your dependency too. Right? Which means that if a dependency validation exception comes from the API, let's say the API said, the date of birth is invalid, we're going to capture that as a bad request. It's going to come back from the API, from the broker that is calling an API. The API will throw 400 exception, say this is invalid, this is bad request. And if it comes in as bad request, this is a broker. Student API broker here. Student API broker. So it's going to capture that from the API. The API is going to say this is a bad student that you're passing in. This guy is going to capture it through RESTful sense. We turn that into HTTP response bad request exception. You're taking that and you're turning it into a dependency validation exception. And then we are taking that and converting it into a dependency validation exception too. With the caveat that we're passing in the inner exception across the stream. So by the time you get to the UI, to your component, when you're really displaying your dependency validation exception in here, what you're actually doing is that you're actually displaying the inner exception of that dependency validation exception. You're basically going and saying invalid date of birth. Right? This invalid date of birth is basically what you're going to display here, invalid date of birth. How did this come through to be like that? Well, the API originally threw that exception, and it went through the broker, it went through the student service, the student service caught that and turned it into a dependency validation, and then the student view service caught that and wrapped it up in another dependency validation, and then it pushed it through to the UI. The UI said, oh, it's a validation or dependency validation. Let me see the inner message. And the inner message in that particular instance is that bad date exception or whatever the case may be. So that's why we're wrapping that up. And we're treating it exactly the same way we treat this one. Well, that's weird. Why? Because if this guy is throwing an exception, then this guy a dependency of this guy. And it becomes a dependency validation exception too. And then the inner message of this, which is the specific issue, not the category. See how the categorization is helping you so much, because if you're throwing null student exception, invalid student exception, and whatever student exception, you have to handle all of these. But if you concatenate all of them into one category, a validation exception or dependency exception or a service exception, it's much, much easier now. for you to deal with these categories, and your code looks much smoother and much smarter. And then you put that out on the UI component. So let's go back here to our code and let's render that. Given when then. So here's what's happening. One of these exceptions happened, right? So what that means is that I want to actually create some information, some data. So let's go here and say student view. You have to pass the validation rules in order for you to get to the dependency, right? So you want to go here and say random. Actually, you say some student view. Why some student view? Because you don't really care. The input here doesn't matter. What matters is how, like the purpose of this test is how you are going to react towards a particular exception when it occurs, not the specifics of the input parameters. Needless to say, it's not the input parameter that actually created the issue. You created the issue and you just want to see how your system reacts to it. That's just a filler in. You just fill it in. So what do we expect? We expect that we will have something called expected dependency validation exception. So this is student view dependency validation exception that takes in whatever parameter we passed in, the calculated parameters that we passed in here. So these can all be encapsulated as an exception, and we could say student service validation exception, right? And this is what we pass into this guy. Great, then we need that exception then. Let's go back to our models here. And let's go ahead and create a new class. And this class is student view dependency validation exception. Put in some copyrights. Let's put in some exceptions in here. And let's say CTOR. This is your inner exception. And let's take from the base and say student view dependency error occurred contact support or something of that kind. And then we're passing in the inner exception. Or rather try again, because it's dependency validation error occurred try again or something like that. Try again meaning that something about what you posted is not right. Go ahead and fix it. Dependency validation exception. All right. How long is this guy? 1.4. I think we're good. Let's go here and say student view dependency validation exception, like this. And then let's mock this problem that we're creating, right? Let's make a big deal out of it, right? The problem that we're trying to create. So let's go here and say we might need to mock the datetime broker, maybe. We'll see. So in here, I basically want to say student service mock setup. So here's my service. I know which method is going to be called. So this is add student async, and I don't really care about what input parameter I'm passing in, even though I created one. I don't really care that it's the same because it's out of the purpose of this. So this is a student view. So whatever student view is passed in, and then throws async, and it throws what? It throws the student service validation exception. Right? Why is this guy mad? Let's see. It is any student, not student view. Student, like this. It doesn't matter whether you map it or not, what comes out of it. Really doesn't matter. I don't want to repeat my mapping logic in here and make sure that whatever is passed in here and say same student as, because that's not the purpose. You got to stay focused on the purpose of your tests. All right, what that means is that it's pretty much, it's going to be very similar to the validation work that we did in here, except that we're going to change some rules. Let's just copy this whole thing in here. It's going to be very, very similar to that. So if I go in here basically like this, the only difference in here is I'm passing in a some student view. That's one. And the exception that I'm throwing is a dependency validation exception. Right? And the exception that I expect is this guy. And actually, all of these have already happened. They must have before this logging issue occurred. because the logging issue is going to be the last thing to happen. So this is going to happen once, and this is going to happen once, and this is going to happen once. I don't know if I need to mock those as well, but let's see. See what I'm doing here? Like this. So we mocked all of these. Now let's see if this actually works out. Ideally, our expectation is that we will receive an exception that says student validation exception or student dependency validation exception. But if we don't need to mock the others, we probably, why did I run debug? Let's do this. So I canceled the overload. This should go red anyway, under any circumstance. But what's the error that I received? It's basically saying, I expected you, see, it says I expected you to throw student view dependency validation exception, but I actually received the student validation exception. Perfect. So I don't have to mock the other ones. Great. I don't know what they're returning, but I don't have to mock them, which is what matters to me. All right, let's put that in here as fail, like this. Commit that as fail. And let's go back here and fix this. How do we fix this? In the try catch in here, I basically want to go and say catch student, see the same order, dependency validation, because the dependency validation exception is going to occur in the student service before the actual validation happens. Someone says, who cares? It doesn't matter. No, yeah, it does matter. Because your code has to be beautiful. Even though you don't necessarily have to get an error in order for you to be a good engineer. Don't let the IDE teach you how to be a good engineer. You should be artistic from yourself, and you're trying to actually be a good software craftsman, that someone who's actually putting in some thought into this, because your code is not just being reviewed or viewed by the IDE, it's being viewed by human beings as well. And these human beings have eyes, and they have minds and thoughts and opinions. So it has to be appealing to them. It has to be beautiful to them. Beautiful. It has to be. So this is student, this is not the student, we want the student, just the student dependency validation exception, just this guy. So these are dependencies. This is a student dependency validation exception. And we want to go here and create something very similar to that. We want to throw, create, and log dependency validation exception, which is student dependency validation exception right here. What does that mean? I need a method that looks a lot like this one here. And no, I was wrong. The student validation exception will happen before the dependency because it does its own validation before it shoots it out to the API. So we're going to chronologically putting it this way. So it's going to be student validation exception like this. And this guy is going to look like that. All right. My statement still stands though when it comes to the making your code readable. Dependency validation exception like this, and this is dependency validation exception. And this is right on the dot, 120 characters. You can see it right here. Right here. Let me hide this guy so you can just see. This is where I see how many characters right in this line in here. All right. Okay, so this is this guy. It's right on the dot, and then this is going to be student view dependency validation exception, which means that this guy is going to be a dependency validation exception, which means that this guy and this guy is basically going to be exactly the same. All right. Does that make my test pass? That is the question. Let's go back to my tests. Let's see here. This guy should go green. There you go. Just like the Hulk. Very, very green. So that's this guy. All right. Then the next test here will be very similar to this. I'm actually going to copy all this piece here. But the only difference here is that I'm handling a completely different level of exceptions, which is the service and the dependency exceptions that are coming from the student service. So in here, it will be service dependency exceptions. Dependency exceptions, which is basically should throw dependency exception on add. So this is not validation anymore. These are dependencies. So this is a service, and so in here the language completely changes. So it's basically student dependency exception and student service exception. See, so now I handled all the 4 different exceptions that may come out of a a student service like this. See how the categorization helps you encapsulate and aggregate these errors upstream as you go. So this is not validation exception anymore. This is dependency exception. And how we're going to react to it is that we're going to throw a student view dependency exception. Not dependency validation exception anymore. It's a dependency exception like this. We're almost done with this service. So this is dependency exception like this. And now I can go and create this this exception in here. I can go here and say there's a new class, student view dependency exception. Here's a file. Here's an exception, ctor and base student view dependency error occurred. Contact support. Oh, now you need to contact support because there's nothing you can do about it. And this is the inner exception. And in here, here's my exception, inner exception. So now that I have student view dependency exception, I can go and say, okay, for these dependency exceptions, I can basically handle all of that work. So let's go back here. Should throw dependency exception on add if student service error occurs or dependency error occurred and log at async. All right, so now my tests look much better. It should throw the same rules should happen. Some student view expected dependency. No, this should be expected student dependency exception. And this is what I'm validating against right here. All right, let's run this and let's see if that actually works. All right. So this guy is failing. Is it failing for the right reasons? Of course it is. We said we're expecting a student view dependency exception, but you threw a student dependency exception. Let's log this as fail right here. And let's go ahead and let's go to the implementation. Let's go to the try catch. And let's handle these 2 scenarios. So first of all, I want to create one in here that creates and logs student view dependency exception like this. So this student view dependency exception, right? And this is all of these guys. So all the way from here. Student view dependency exception like this. And then in here, I want to handle these 2 exceptions just like that. So here's these 2 exceptions here. So this is student. What happens first? A student dependency exception may happen more likely than a service exception. And this guy right here, and this is my student dependency exception with a lowercase s because it's a variable. And the same thing happens here with a lowercase s because it's a variable. And then instead of a validation exception, I'm saying student dependency exception like this. There you go. So I'm creating a student view dependency exception and handling all of these cases. Let's go back to my test and let's see if that's actually the case. My test here, run. And it passed. It passed simply because we are taking care of these exceptions as well. So that's a pass. The last thing in this service, so we can turn this guy green, hopefully. We want to turn this guy green, which is this guy here. The last thing that obviously this is all just the post scenario, sending a student to the API. The last scenario I want to handle is a scenario that is very simple. It's very similar to this. The only difference here is that it's not really a dependency that I'm dealing with. It's any exception that happens other than these particular cases that I handled specifically in specific ways. So this should throw service exception. This is anything, memory leakage. This is the catch-all part. Exception on add if service error occurred and log it async. So instead of all of this, it's going to be a student view service exception, which we're going to create in a second. And inside this guy, we want to create a var service exception equal new exception like this. And we want to throw that guy in there. And we can hook this up to anything really. Like the service exception could happen out of literally anything, right? For the purpose of this, because we're calling the user service, let's hook it up to the user service. It could happen from anything, but the closest one, the one that we call the most, the nearest, is the one that we need to take care of and actually hook up that exception to. Sometimes you don't have any dependencies. You want to probably figure out a way to cause an error or an issue in your input parameters or something like that. Let's just go ahead and create that exception first. So in here, I'm going to say exceptions, class, student view service exception. Here's my copyrights, exceptions like this, CTOR, and here is my inner exception. And then under this, here's your base, and then you can say service student view service error occurred. Contact support. At this point, there's absolutely nothing the user could do. You have to contact the development team so they can go look at the logs and see what actually happened. Let's go back to our tests. So this is my service exception student view service exception. And this is the service exception that comes out of the user being logged. And I don't really care much about the validations that happen in here. Since this guy is not even asynchronous, I think it's throws. So it's not really throws async. So this guy is called once. And then this guy is called, in this particular instance of the service exception coming from this guy, like this. And then the rest of those are nevers. Nevers because they never get called because this is where the issue happened, like this. All right, so it should throw service exception on add if service error occurred and log it async. We're throwing student view service exception like here, and we're passing in some student view and whatever the exception may be. Let's run this guy and see if it fails. So this guy is failing. It's basically saying I expected you to throw a student view service exception, but you throw just a generic exception. Let's put that in here and say fail. And the last thing in our very long session here, and I apologize for the session and the long session, we're gonna need to create one in here that's for creating and logging service exceptions for student views, like this. And this is my service exception. This is my service exception like this for the most part, and everything else should be just the same. Which means that on this level here, I want to say catch exception, service exception. I'm going to go throw, create, and log service exception with that service exception passed in. This should basically be all the exceptions that you want to wrap up. You can see because we're canceling the noise of the exceptions, your business logic is still simple and intact because all the exceptions are exceptions. They should be at the edge of the world. They shouldn't be what you see every single time. That's the noise cancellation, exception noise cancellation. Let's go ahead and run our tests. Control minus makes me go back. And then let's go here and say control and click on this guy. And let's just run this guy and see if that works out. Here you go. Run the runnies. And we have succeeded. So that means we have fully implemented a view service that handles all the issues that may come out of a particular service. Now, once someone might ask and say, well, Hassan, you also have dependencies on the user service, right? But the user service isn't completed yet. So we're hoping that anything that happens there, you know, it will be caught in the catch-all service exception and say something happened. By the time we get back to the user service and we talk about security and authentication authorization, it should be very easy to come back here and add all of these things in there. All right. Now, with that being said, that basically completes this guy. Now I am ready to push all my changes all the way upstream like this. Let's push all my changes upstream. Push. So all my changes have been pushed to the master branch. You know, if you have any questions or comments, make sure you know, I will make sure I attach this in the description of the video. But everything is already living in the let me open up a new in the repo. So if you go to GitHub in here, if you go to GitHub and go to OSSS portal, you'll see all my changes, all the commits in this particular endpoint. All of it is in here. See, fail, pass, purest approach, full test driven, and all the videos that I am recording for this particular system as well. All of these videos are also in that portal, and there's also a Teams channel where you can go in and just join the Teams channel. If you want to ask me any questions right away, I'd be more than happy to answer your questions. So with that, that means that, you know, our service in here can go green finally. So we would implemented this one. And with that, that concludes our session today. I apologize for the long session. I understand that, you know, some of these things take longer times than others. But, you know, in general, you know, what I'm trying to show you here is the real life implementation. Like, what are the steps, what it takes to actually build proper software. A lot of people say, I want to build, you know, solid software. And then they get lost in this mess. You know, on the internet or the outside world, everyone has a way, everyone has a school of thought, everyone has, and there is half-baked theories, half-baked patterns, and half-baked architectures. There are people that, you know, put in a lot of time and effort. You know, people like Uncle Bob, people like, you know, Martin Fowler, David Fowler, people that actually put time and effort and always on the go to teach people. Sam Newman, for instance, they're always out there teaching people things, trying to educate people and putting as much content as out there, whether it's written format or video format or actually in person, practically pairing with people. But in general, you know, it takes time. What I'm trying to tell you here is that it takes time to build proper software. It also takes time to build solid software. So this is why I say, like, a lot of people say, you know, learn C# in 10 hours or learn C# in 7 days. It'll give you a good view about C# in 7 days, but if you actually want to build something worth its while, something rigid, something strong, industrial, something that people can use to put it in a spaceship or use it into a medical system where it's saving people lives, or putting in an educational system like this software that we're building right here. If you want to do that, then this is the way to go. This is the option for you to go. And with that, I'm, you know, I'm sorry again about the long session, but if you have any questions or comments or concerns, please feel free to reach out. I'm on all social media channels. Just reach out. I'll try to answer your questions, address your concerns and comments. And I hope that you learned something today. And don't forget to like and subscribe. And I'll see you in another video where we actually start building the real UI components. And this is where I get to show you the beauty of Blazor when you mock all these services that we worked on, and then you see whether it's rendering the right UI on the front end. And this is where you get to learn about BUnit and all of these nice frameworks that will hopefully potentially help you, even if you haven't built any UI in the past. It doesn't matter, because I have it on record working with engineers that never ever knew even C# or never even touched the UI and let go React or Angular, or having any experience with that, and today they are able to build entire systems end to end, with from the back end all the way up, from the database all the way up to the UI, by themselves in a very, very short period of time. So stay with me, stay focused, and be patient. And I hope that you enjoy this session and this series in general and the upcoming sessions. Thank you so much for watching. See you soon.